don't know if Laura wanted to sit down before she present, or is she just coming up and then going off stage?
Oh, okay. So the only, is it six?
So seven. One,
Yeah,
two,
seven.
three, four,
Oh,
five,
okay.
six,
So
seven.
there's no seat for the Laura.
So yeah, you guys are standing. Is that okay? I can push it down and
I
try
don't
to grab
mind.
it.
I wanna stay here.
Okay. Do you want me to do one for Laura, or will you just tell her to sit here?
If you prepare the seat, but it's already full. Yeah.
Yeah.
Oh, there.
This
Yeah,
one,
yeah, yeah,
this one's
one,
empty.
yeah, should be. Okay,
The
so
rest are
Laura
going
should
down.
be here.
Okay.
Should be easier.
Perfect.
Aloha! We're looking for the breakout session leads. Please come up and sit down on the table.
Thank you.
Well, not on the table.
Oh.
Do you have a special order? Do you want us to?
I think there's a name here. Yeah.
Or do you want me?
Laura is here.
Do you want us to just speak from the sitting?
Yeah. Please do. Yeah.
So you're going to go first?
Yeah.
Yep.
We should already start. Hello.
Oh, we have a minute. We have a
Morning.
minute. I think you should start.
Can I start? Okay.
Just the
Ladies and gentlemen, could I have your attention, please? Okay. Aloha. Wake up, people. Aloha. Good vibe. Okay, welcome back to the day 3 of the Ocean of 19. I am Sanae Chiba, one of the program committee member from Jamstack, and
Frank Mueller-Carger, another program committee member.
And we will start today with a report out of the previous day. So the daily theme of the yesterday was information. So we here have 8 speakers to represent to report out the outcomes and the recommendation of the information plenary, the panels, and the breakout sessions.
Well, this is pretty exciting. And yesterday we had the first 7 breakout sessions and 5 special sessions that help collect your thoughts to shape the outcomes of the meeting. There are some things that I would like to ask for the breakout sessions that are going to happen today that we learned from yesterday. This is a whole experiment for us. And what we saw is that there were some of the breakout sessions had speakers and panelists that took too long and limited the input that we wanted to get from the audience. So those, the session leads for today, the breakout session leads for today, please allow enough time for questions, but also for discussion, plenty of discussion. We want people to get their recommendations into the breakout session recommendations and then the outcomes. It's very important, and there are a lot of people that asked us to emphasize that. So the way that this is going to work today is that the breakout session leads and the people that are going to report out on those provided 3 top-level recommendations that they would like to move into the outcomes of Ocean Ops 19. So what we're going to do is we're going to show you those, and they're going to be shown on Slido. They're already on Slido. They're live, and you can see them on the screen maybe later on. But they're going to talk about it. What is going to happen here is that you can opt in. You're not going to vote for the recommendations. You're going to opt in. So if I can ask that you don't vote or opt in as anonymous, if you want us to contact you later and be involved in the process of how we roll out and manage the process of moving for the next decade, and you want to be included, please opt in with your name when you click on each one of the recommendations. You can vote for as many as you want. You can be involved in as many as you want. So if there's any questions about that, I hope not. It's very simple if you go into Slido, but just don't vote or don't opt in as anonymous. Okay?
Okay, so we have only the 1 hour. So first, let me bring up Laura Lorenzoni from NASA to report out the plenary and panel.
Thank you, Sana and Brian. I will report out on the plenary that we had yesterday morning as well as the panel. And it was really hard to synthesize. There was a lot of good discussion and really great questions throughout both the panel and the plenary. And so what you're seeing on the screen is just a high-level overview of some of the most salient points. But by all means, rest assured that we've captured all of your input. One of the things that really resonated across the entire morning was the big gap that exists in coastal observations. Both in terms of observation and information, and the geographic disparity that exists where observations are taken. During the panel, technologies such as using animal telemetry to fill those gaps were briefly discussed, as well as other ways that we can address this need. There was also discussion on how we need to close the gap between the coastal communities and the open ocean communities. And so there's a lot of work to be done. Another one of the high-level points that we wanted to summarize from the morning was how we need to really co-design and co-develop the observance system for the future. And that includes a holistic and a complete value chain, including businesses and governments. But it has to be a circle. That has to be feedback. So there has to be a supply of the data ready for the user, and then the user needs to provide some feedback to the observationalist on how what the usefulness of these data are. Something that everybody agreed throughout the entire day probably is that funding across the life cycle of the data is needed. So we need investments in a curated archive or curated archives and activities that do synthesis products. There need to be cross-disciplinary experts to synthesize the information and come up with support of products. There needs to be a harmonization of data fit for the different communities. The needs vary broadly depending on who the end users are. And there needs to be support for this. And one of the communities that was discussed was the modeling community, and how there is a real barrier between the observing data that we gather and how they can actually utilize these data in their models. There needs to be improvement in communication and awareness among the different users. It's pretty clear that we oftentimes don't talk the same language, and there's a lot of work that has been done, and there's plenty of work that can still be done to close that gap. Data recognition is needed regardless of where the data are. There was also discussion on how data constitute a national asset and an important resource. But regardless, data needs to be discoverable, and that is one of the biggest barriers that we're also facing for the usage of the data. And during the plenary, there was discussion on how the next generation of observers really need to pay attention to critical scales, and the mesoscale and sub-mesoscale research was mentioned. And that's about it for the plenary and the panel.
Very good. Just the audiovisual people asked me to tell everybody on the stage here to talk into the microphone, and maybe at this distance is a Hawaiian symbol, so about this distance. I thought Laura was going to do this. So we're going to introduce the breakout session reporters. So first we have Claire Jolie on the blue economy and sustainable development.
Good morning, everyone. Do you want to show my recommendations on the screen?
Let's see if you...
So we had yesterday a very good session where we discussed the social economics of ocean observation, linking observations to sustainable development in a growing blue economy context. We had 5 very good speakers bringing unique perspectives, national, global, and industry perspectives, namely Greg McLean from NOAA, Vladimir Yabinin from IOC, Per Fitzix from Kongsberg Maritime, We had Tim Moltmann from IMOS in Australia, and Ralph Rayner from LSE and OIOS, who actually really co-chaired part of the session and brought some perspectives from Oceans Ops 2009, where he actually chaired a session very similar to the one we had yesterday. So it was interesting to see what had happened in 10 years. So as a result, and echoing some of what we heard in other sessions already over the past 2 days, we found that measuring value, socioeconomic value, from that very diverse ocean observations would really help to make the case for further development of the systems. And I think that's crucially important as we look ahead. And not only would it help in terms of helping the decision making, but it also would contribute to formulate a stronger message towards society in general. So that's why, it's basically one of the major point here. But to do this, we have 3 recommendations that came out of the discussions with the participants. First, we need to foster transdisciplinary research that goes much beyond multidisciplinary cooperation. To do that, you have different ways that we started to discuss. I can come back to that later on with you if you want. But at the end of the day, the idea is not to bring an economist at the last minute, as to actually build up the systems with social scientists in mind. Another recommendation concerns the mapping of value chains, linking specific observations, whether they may be geophysical, biological even, or full information products to end users. Again, the primary value we see from ocean observations is obviously science. However, there are many derived benefits that deserve to be mapped out. So we see indeed a range of benefits, and that leads into our final recommendation here in terms of, we think we are at a stage 10 years after Ocean Ops 2009, where we think the community can benefit from best practices in socioeconomic valuation. There are already initiatives, isolated initiatives in different parts of the world. At the end of the day, we believe it would be worth for the community to have such a catalog of case studies at local, regional, and national, even global scale, as to contribute to the community's plan in actually building up the next systems. At the end of the day, we want to avoid reinventing the wheel again and again and again, and there are many cases that exist already. So with this, that's it. So mahalo and pau. Done.
Thank you, Claire. So the next breakout session next breakout session is capacity building, and lead is Brian Arbick, I think.
No, so Alexis.
Oh, sorry, bad communication. Okay, the capacity building lead is Alexei Valery Autumn.
Good morning, thank you. I'm here representing myself and my co-lead, Brian Arbick. We were really excited to have almost 80 people representing most corners of the world in our session yesterday. And prior to our session, we asked our registered attendees to let us know what some of the challenges were that they faced with capacity development. And not surprisingly, funding was the largest challenge, but another one was a lack of basic oceanographic infrastructure in the regions where they were working. So based on that, we formed 6 breakout groups within our breakout group, and each of these groups started sketching out activities that they thought would enable effective capacity development over the next decade. And given that funding is such a priority, we sought to ultimately turn this into a prospectus that we could deliver on the global stage. So the 6 groups were focused on ensuring effective capacity development, collaboration among those conducting capacity development, funding and community buy-in, the physical infrastructure needed, the training and knowledge infrastructure, as well as the non-scientist capacity building. Each of those groups came up with a series of recommendations, and we did our best to distill all of that into the 3 recommendations that you see here. The first recommendation is that we felt there was a need to create a community of practice for those who work in capacity development, and perhaps we could utilize existing frameworks such as POGO and IOC to house such a community of practice. And this community of practice would enable us to share resources so we don't duplicate efforts, create a unified agenda and perhaps a funding request, such as a prospectus, and also trying to support each other in ensuring sustainability of efforts and continuous presence in the regions where we're working to enable local oceanographic capacity. The second recommendation we have is that any capacity development activity needs to, from the very beginning, align any efforts with community needs and realities. We discussed the need for any equipment that is provided to be equipment that is actually available in the place where the end user is, and perhaps creating regionally specific best practices on how to obtain and maintain that equipment, given the complexities of customs and shipping. And importantly, to make sure that the equipment and infrastructure that is provided is easy to maintain remotely without requiring sending it overseas for tune-ups. And our final recommendation really was around how we felt that capacity development in oceanography is not necessarily recognized in high-level forums as a need, so we need to create more opportunities for dialogue, whether those be things like side events at UN meetings or other venues, for dialogue between those conducting the capacity development and high-level decision makers, but also local implementers. So really just creating venues for dialogue. And all of these recommendations, we hope to summarize and provide much more detail in a series of documents that we'll be preparing over the next few months, including a global prospectus. And again, our goal as people who work to develop the capacity of coastal communities to monitor the ocean is that when you look at a map and you see assets, oceanographic assets, every single coastal country owns and operates an asset on that map, that there's true data autonomy from around the world. And we believe that these 3 recommendations would help us achieve that.
Thank you, that was good. Next is Karina von Schuckmann to talk on the summary on climate change and variability.
Thank you. Could you please put up this slide? Thank you. So we had a session on the climate change and variability, particularly was based on the indicator framework, a global climate indicator framework as established by the World Meteorological Organization and the Global Climate Observing System. And we had topical contributions from different research at top levels. Researchers like we had ocean heat content presented by Tim Boyer, we had sea level presented by Annie Kazenav, we had ocean deoxygenation presented by Salivin, we had ocean acidification by Libby Jewett, and LC by Megan Gronin, and sea ice by Fiammetta Stranino, and followed by a panel from Pierre Latron, David Legler, Wedang Yu, Taron Lamont, and Dilep Stammer. So the point is that these indicators lie at the very end of the added value chain and give us the opportunity to deliver information on the one hand to stakeholders and decision makers, but also open an awareness and sensibility to the need of sustained observation and to the need to increased observation improvements of the observing system. So we come up with 3 recommendations. Well, the first one is the augmentation and refined definition of the global climate indicator framework towards a comprehensive Earth system view. The point is that the existing indicator framework, we recommend to add some more indicator topics in order to move forward to an Earth system view and to be very comprehensive, so including a large-scale ocean freshwater content based on the essential ocean variable salinity to induce RC fluxes and CO2, heat, oxygen, freshwater, and momentum. Also to include ocean deoxygenation as an important part based on the essential ocean variable for oxygen and circulation part, in particular the meridional ocean circulation transport. In addition, there was be highlighted that this global climate indicator framework should envisage to have a regional aspect, a regional indicator framework, and to better highlight on the one hand the documentation of these indicators and the role of the observing systems for the indicators, to highlight that for establishing a high quality accuracy indicator that there is a sustained and an improved observing system needed. Next slide, please. Recommendation 2 was linked to achieve the accuracy target of the essential ocean variables and essential climate variables, which nourish those indicators in order to calculate those indicators at required accuracy. So there's a set of recommendations for this very important part for the essential ocean variables and essential variables to feed the global climate indicators, which is sustained observation, the spatial coverage to fill gaps, regional and coastal, and also in the vertical part of the ocean, complementary new measurements platforms and new parameters which had been not taken into account so far, a sustainable reference data for validation, enhanced communication between the different disciplines and the managers, but also with the stakeholders, with the users, and international standards for formats and grids, sustained research and development for improved accuracy and uncertainty evaluations, and sustained international assessments, including on the indicators itself, but also for risk assessment. Next slide, please. Recommendation 3 is reduce the capability gaps for the essential ocean variables and climate variables to nourish, again, the ocean-related global climate indicator framework. Those are linked to adding variables, which are currently missing or under discussion, as for example, leak. Advance on technical challenges, for example, on bottom pressure drift, oxygen sensors, also highlighted, which is not added here, biases in the RC flux, measurements, long-term stability and accuracy, the very important point for most of the parameters, and again, research and development in order to improve or get rid of existing biases. The filter sampling and coverage gaps, vertical sampling, so it's a big issue in particular, which new programs under the way to further support the deep Argo, the marginal seas, the high latitude areas, seas and ice zones, the boundary current areas, and also the shelf zones. There's also a need to ensure a sustained funding mechanism to ensure that this is also a very important gap on the observing system, particularly to be sustained and to meet the accuracy needed for these indicators, and also data accessibility. Thank you.
Thank you, Karina. The next session is ecosystem health and biodiversity. Then the session lead is Ana Seguera. Could you please put the slide on? Thank you.
Yes, I'm reporting on behalf of the leads, so Maury Estes and Gabrielle Canonico. I'm reporting the main recommendations from the Ecosystem Health and Biodiversity breakout session, which was planned and organized by a team of 16 people from a range of universities and institutes in the USA, Canada, Europe, and Australia, all with a range of different interests and varied expertise. Our starting point was this common vision to enhance integration of biological observations in the framework for ocean observation and a mission to develop a decadal implementation plan for successful integration. We decided to organize our workshop around 5 major themes of blue economy and ecosystem services, stakeholder requirements, what to measure, indicators of ocean health, and observation and deployment technologies. These were also the topics that we used to draft a first version of this decadal plan that we propose, and we circulated this draft by the community prior to the conference about 1 month earlier to encourage comments and participation. This is because our commitment is to try to work together and to recognize synergies while we develop this plan, and also to ensure that biology, biodiversity, and ecology are fully integrated into ocean observing systems and efforts. We see this as a priority for over the next decade to assist measuring and assessing changes to ecosystems and human health. The comments we received so far, just a quick overview, included the needs to create and use common methods and best practices to improve interoperability and reproducibility, to highlight microbial monitoring, to link existing biological and ecosystem essential ocean variables, to stress the importance of plankton surveys, and so on. The call is still open though, so we can still receive comments, and we also have a call open for volunteers to work with us on this draft after the conference to try and complete this roadmap. To encourage contribution, during the session yesterday, we had live polls on Slido. So after each theme, we open an online poll. And we also have currently a survey that is still open until the end of this week. So anyone can just go to Slido and browse to ecosystem health and biodiversity and have the opportunity to send through comments and questions. So we still very much encourage your contribution and participation. We expect that you all engage with us, of course, because this needs to be a joint effort from the community, and it's also the only way to make sure that our common voice is heard and captured in the document that is going to be used as a roadmap. This leads me to the 3 summary recommendations, which are on the screen now. So the recommendations are to integrate biological observations into the global observing system as an integral and necessary component of the ocean ecosystem science and understanding, to implement available technologies for biological observations now, so we can maximize access to biological data and information, to then quantify, explain, and forecast biodiversity changes, and to advance decadal plans for a fully encompassing global ocean observing systems. That means an observing system that integrates physical, biogeochemical, biology, and biodiversity observations. So as a community, the feeling is that we are ready to do this, and we do need commitment from all to pursue these recommendations as a priority and to engage so that implementation happens in the next decade.
Thank you, Anna. And now we have Francis Galgani to talk about the Global Observing System for Marine Debris.
Thank you. Good morning. Good morning, all. It's what? Okay, good morning, all. So the session yesterday was very active with many questions and comments. Recommendations were prepared after a live poll, and 5 recommendations were taken and merged together to come to the 3 final recommendations. What is important to say is that we have a special context because the scientific community is enlarging with more and more topics addressed. But the support is coming from the strong demand we have from stakeholder, policymakers, industry, citizens, and so on. So what is lacking actually is a global monitoring, and most of the recommendations are dealing with that point. So now the door is open. This is where we are going through, and the 3 recommendations are that we need a comprehensive global observing and information system. And this will enable to evaluate source, abundance, trend, risk, and so on, but also the efficiency of reduction measures. So it's not just only a scientific approach, but also a social need. And this will lead to the possibility of control problem, hopefully. Then to achieve this, we need to develop efficient in situ observation technologies. So that could be satellites in some cases, for instance, remote sensors, drones, and so on, models, monitoring strategies to improve what is existing actually. And the point also for Monitor is that we may and we must involve citizens because they are really directly concerned with the issue, and they may bring a lot, and there is really an interest from them, and that's quite important for marine debris. And then we need to work together, building an integrated, standardized, and harmonized collaborative network. We need commonly accepted methods, we need intercalibrations and so on. And we do have also to use that to answer fundamental scientific questions and societal demands. And then finally, we had some discussion about the way forwards, and what will happen probably is that UN will organize a workshop, and we had some institutions such as GOOS proposing also support to the work to be done in the future. So in a way, we have a chance to go for something better during the next decade. Thank you very much.
Thank you, Francis. Next session is Integrated Ocean Observations 1. This is the first one of the series of 3 sessions. And the session lead is Jack Barth.
Thank you, Senai. Good morning, everyone. So we had a lively session with about 300 of you in attendance, and I remarked that that was the same size as OceanObs 99. So we had a whole session on integration. And maybe just right off the top, one of our major thoughts was that we've really come a long ways in 10 years on integrating sensors and platforms, putting together the physics and biology and biogeochemistry on platforms to address problems. But there's work to do to integrate across scales. So as Senai said, this is the first of 3 sessions we were tasked with across geographic scales. This afternoon, they'll talk about across user groups, and tomorrow across disciplines. So please join us for those. So connecting across scales, and we couldn't have been set up better than the morning sessions where people were saying, well, where's the coastal community? Are they talking to the deep ocean? And I'm here to report the coastal systems are alive and well, and we do talk to the offshore observers. There are profound examples of that connection through marine heat waves, crashing ashore, through upwelling of low DO water, low pH water right onto our shores. And I think that across scales gives that connection from the local needs, information for the managers and policymakers, and then it telescopes out across scales to the open ocean. So we reviewed some coastal observing systems around the world, Australia, Europe, in the US, and also a proposal to look at the boundary currents and boundary systems around the globe. We then transitioned to a quick discussion of EOVs and best practices. And we did a poll about the various EOVs with the question, what do you see us routinely measuring in the next 10 years? And I'll just mention that in the physics category, there was the usual suspects, but there was also many votes for the surface heat flux. So that was good to see come out, as well as the emerging bottom pressure EOV. In the biogeochemistry component, dissolved oxygen, nutrients, and dissolved organic carbon. And finally, with biology, the group thought that the phytoplankton biodiversity and abundance would be measured, as well as fish abundance and distribution. So then we talked about some basic points before we got to our recommendations, and one of the main ones is that we ought to now turn our attention to the services and what information we're providing. In the coastal systems, we're doing an okay job of integrating with sensors and platforms to attack a problem, and now it's really time to get that integrated for providing the services or the information. We talked about data systems in the best practices context, and we realized that data systems should be interoperable. And then we should pay attention to the diversity of data sources and different uses. There's, the research quality ships, et cetera, as well as voluntary observing ships, and citizen science. So we boiled down to 3 recommendations. Number 1, make sure we're measuring the same important EOVs in comparable ways across scales, so that the coastal systems can look to the deep ocean for those source water characteristics, and then the coastal productive areas fluxing material and carbon offshore can interact with the deep ocean observing. Number 2, we need to, as mentioned by some of the earlier breakout reports, we need to expand those EOVs, not just add them wherever we like, but to really focus on co-locating the biology and BGC, central ocean variables, alongside the physical. And then lastly, we need, along this idea of capacity building, we need to build the ability for these comparable measurements to be made all the way from the coast around the globe out to our deep ocean system. So that was a capacity building recommendation. So thank you very much.
Okay, good morning. So the overall goal for the ocean weather and climate forecasting breakout was to provide high-level recommendations on how the observational community can benefit from increased synergies with the ocean weather and climate forecasting community. So the way we did that, the session with first short presentations on some of the overall recommendations that came out of Ocean Predict 19, some presentation on high-level international organization as far as MET and ocean services, presentation on the connection with the coastal environment, and then OSC's ocean simulation experiments and OSCEs. After that, we broke the breakout session into small breakouts by tables of 10, so we had about 10 to 15 tables. And for about an hour, we asked them to address the questions that are on the screen right now. And specifically, what are the key steps we would need to take to facilitate knowledge exchange between the ocean observing and the ocean Earth system forecasting community? How can the ocean observing system better leverage and benefit from data assimilation verification capabilities? How can we work with the observational community to help pull through their innovations and improvements to maximize societal impacts? And what observational impact studies would be valued by the observational community? So the small breakout groups discuss that and other things, and then we asked them to provide some recommendations and put them on Slido, and then they could, vote them up or down. So if we can go to the next slide, please. So the recommendations that we summarized is to develop in partnership with the observational community a framework to perform observational impact studies. I mean, we do have OSCs, OSSEs that are done occasionally here and there, but there is not a concerted effort to do so in a systematic manner. And for example, we could envision a global nature run or several that would be community endorsed and then could be used to perform those impact studies. So what was suggested is to have a forum where the various ocean impact studies for all kind of applications from the coastal all the way to the global could be assembled and discussed as a function of various user needs. And maybe the last recommendation, which may be the most important one, is how do we, to work and align the strategies of the various groups. I mean, here we put Goose as Ocean Predict and Blue Planet as an example of observing ocean prediction, and then users centered. I meant so many others, but if we can align their strategy of those groups together, I think we would be also much more productive. Thank you.
Thank you, Eric. So those breakout session be done in only the 2 hours, really short time, but please keep the discussion during the conference and also after the conference. So please give a round of applause for the lower and all the session chairs. Okay. Also, beside the breakout session and the plenary and panels, there are the 5 special sessions organized by the sponsors. And unfortunately, we don't have enough time to ask them to come here. So instead, we will read out their recommendation here. And also, their recommendation also on the Slido. So please don't forget, put your input and select the opt-in, the recommendation, what do you think is most important for the next 10 years? Okay, let's start read out the recommendation.
Yeah, if you can put the slides there.
Okay, let me see. So the first special session is an ocean of data, as NOAA's role in marine extreme event and hazard, as it's organized by the NOAA. The first recommendation is bringing core mission stakeholders earlier on in the development of research and technology, so that we are developing around the needs and in tandem, providing the necessary communication and education from the onset. The second recommendation is be more adaptive to changing technology and focus effort on the transitional system while maintaining data records. The third one is a research to operation transition a key in developing systems with broad-reaching impact and social benefit. This needs to be a focus from the onset of research questions to support issues and need on multiple scales.
Thank you. The next slide, please. We had a special session on sustainable fit-for-purpose ocean observing systems and responding to user needs. The recommendations were to have feedback processes with identified users and resource stakeholders, and that they have to be done from the beginning. Case studies can highlight the value of ocean observing information so that nations that want to commit to sustained observation activities can do so. Take into account existing pieces, commitments, and regulations for developing a fit-for-purpose ocean observing system, and define targets and success indicators for a fit-for-purpose ocean observing system by 2030.
Is it one?
No, it was already up.
Oh. Sorry.
Okay, very good. These are the recommendations from the harmful algae bloom that was led by Clarissa Anderson. The ocean observing community must advance an end-to-end ocean observing system that responds to marine-related societal needs and that provides improved advanced warnings of harmful algae blooms. The integrated observing system should fill the essential need for sustained, preferably automated near real-time information biology to include HAB species and toxins and improve forecast systems that address the HAB risk warning requirements at global and regional needs. And then the system will scale up from regional networks to a global framework through interregional technology and product development that addresses societal needs, while sustaining multidisciplinary and climate quality data to ascertain long-term trends in HAB occurrences. Next.
Can I take this one?
Yes.
Okay. Thank you. Next session is end-user engagement, a perspective from China, and organized by the Chinese sponsors. The first recommendation is improve coordination across different levels of the ocean observing through enhanced dialogue with observers and users, for example, through a consolidated network portal. And the second recommendation is support tailored best practice for technological innovation, particularly at local and regional levels.
Thank you. We have a last special session on the ocean observations and the blue economy, but I think we don't have any recommendations submitted for that, but I think they're very much in line with what Claire Jolie mentioned earlier. So I think that we have to thank the enormous amount of work that went into these breakout sessions. We went through these, we arrived at these breakout sessions through a very long process of trying to bring the people that had written community papers together and distill them down into a manageable number of breakout sessions. So it was a long and arduous process, and we're still learning. Hopefully the ones today are gonna be just as good as this ones today. Thank you very much for everybody's recommendations. We are actually a little bit ahead of time, so I think that if we want to, you want to move on? Okay, no questions.
Okay. Okay, so I think this is a time of wrap up, and I would like to thank you again. We'd like to thank you for everyone participated in yesterday's innovation event, the session convener, participant, and all the speakers. Okay, thank you very much. And now, up next is a kickoff of the Innovation Day plenary. So please, Justin and Monina, come up to the stage to take over us. Thank you.
We got it. Good morning, all. So, welcome. We can try the aloha thing. Aloha. Aloha. Excellent. You are paying attention because it's about to get difficult. We've had all this awesome technology. As a reminder, all those recommendations you saw go by, there's options in the Slido app to be opting in, which is really just saying that you're interested and you'd like to participate further in that conversation. But I'd really like to start Innovation Day. I'm going to throw that first slide back up, thanks. So it's Innovation Day. It's Wednesday. We're not quite halfway through the week. We want to energize you. And I'm going to start by making you do an old school analog poll. This means raise your hand. So, how many of you believe you're an innovator? Excellent. If you don't think you're an innovator, how many of you believe you're a problem solver? Okay. If you don't think you're a problem solver, how many of you are at least a curious human being? Come on, we all should be curious, right? Excellent. Okay, so now that you've moved, you've shaken it up a little bit, what we're going to do today is we're going to engage the topic of innovation, and it crosses lots of boundaries. The slide you see in front of you has a lot of pictures of technology. A lot of times we think about technology when we think about innovation. But over the course of the day, we're going to be talking about process, and we're going to be talking about human beings, right? So at the end of the day, all innovation comes from us as human innovators. So to set the stage, I'd ask you, as you look at those pictures of really interesting pieces of ocean technology, think about how far we've come, right? In instrumentation, long, long ago, some pioneering ocean scientist took a mercury thermometer and put it in the water to measure temperature. And then we moved on, and we have electric instrumentation that produces measurements, digital output of temperature. And now we're even seeing digitization through environmental DNA of biological information, right? Our sensing capacity has evolved dramatically. Maybe you're from the remote sensing community. And we started equivalently with the idea of Sputnik flying in space, and then eyeballs in space. And then we had instrumentation that can measure sea surface temperature from space. And now today we're watching space be democratized by low-cost CubeSats and private sector entrepreneurs. That's changing your game. Maybe you're a platform type, and you come from a history of maybe buoys or boats, and today you're thinking about bots, right? All of these technologies are changing and evolving, and essentially what I'd ask you to consider as we start through our day here, our innovation day together, that the potential for future innovation in ocean observing is at least as vast as the ocean is itself. With that, I'd like to hand over to my colleague Moninia, who's going to kick off our formal program. So thank you.
Thanks, Justin. So my name's Moninia Owen. It's a pleasure to be here today. We've been working towards this day for a good couple of years, so I hope we really enjoy it. We're going to take it up a notch for Innovation Day. We have some slides here to recognise the effort that the team, how do we go backwards, have put into our community white papers. So a lot of people have put in a huge amount of effort over the last 2 years to come together. We had our 450 abstracts, smashed them down into 140 white papers. If Frank had his way, we'd have one white paper. We took that challenge. So anyways, here's a beautiful word cloud of some of the words that came up in the white papers that we kind of classified as innovation. Now, that classification was a bit tricky. I think many of the white papers had ideas of innovation, but to synthesize 140 into this one word cloud and into this set of slides was a bit difficult. So if you find that we've missed something, by all means, let us know. So our classification system had about 18 of the 140 white papers as innovation, and that in and of itself is kind of telling. You know, we got what we got, but we've got to get out there and be innovative and really connect with the people in our community who are innovating. And I think that's a really important message. There are loads of people out there, but they weren't sitting at their computers writing white papers. They were actually doing the innovation, which is really cool, but we need to connect with them. I'd like to acknowledge the effort of the lead authors that we've put up there, and I just say, I apologise if your name's not up there and you consider your white paper was innovative, by all means, come and let us know. Of our cross-cutting themes, we had 59% of the white papers sort of dealt with networks, a few of them with data systems, and then governance as well. So the key ideas that came out through all of the white papers in this space, we're asking ourselves, how can we spur innovation in observing technologies, products, and user services? So we had a range of focus areas that the themes came through: developing low-cost, high-value platforms. Everyone's got a GPS on their phone. Everyone knows low-cost platforms are the future. Increasing lifespan and runtime of systems, so long battery lives, sensor swarms, better autonomous sensing. And linkages between remote and in-situ observations is a key one. And more sensing is needed in extreme, remote, challenging environments. Undersea ice, polar regions, the Pacific Ocean. So there's lots of opportunity there. In terms of needs, the key themes were increased data resolution, sustainable observations, that's a key one. The accessibility of products, making our data available, data products. No point collecting data just for the sake of it. It's all about the users, the uptake, the data products. And the key theme that always comes out, sustained funding for R&D and for research. So hopefully we've got some speakers that can speak to some of these ideas today. There are a lot of technologies that were addressed in our community white papers, and these are just some of them. And there are also other technologies that perhaps weren't addressed in the white paper. So there are gaps, and these technologies that are here were identified as addressing gaps in the observing system. So unmanned systems, it's a theme you'll hear throughout the day. Unmanned surface vehicles, there's lots of potential, lots of capability there. Obviously remote sensing with the missions that are coming up over the next couple of years, loads of opportunity. High frequency coastal radar was a theme that came through, sea level measurement, swarms of drifting buoys. These are the future, and then the ability of cable systems to provide large amounts of data. So we're going to be talking about some of these themes throughout the day, and we've got some excellent speakers that will also address them. I think I'm handing over to you, Justin.
You're right.
Here you go.
I'm back. This is the tag team. Innovation in itself. So to dig in just a little bit, and to be clear, with 18 different papers and many authors, this is not meant to be exhaustive. It's a flavor. It's a sample. And not surprising, technology development is an area where people believe innovation is important. And I don't think it would astonish anyone that there's demand in this community for new sensors and new technologies. Perhaps more interesting is the nature of some of the new sensors that we see bubbling up in those white papers. Biological data, waves, right? Here we are in Hawaii. We all want to find the best wave, right? So waves are important. Biogeochemical. There's an ever-growing array of variables that the community is interested in, and I think that speaks to the success of our history of learning how to observe certain core variables, and now we're hungry for more. And of course, thus, with new data and new information come new fields of research and monitoring, and again, it shouldn't surprise anyone at this point in the program, eDNA, genomics, also litter, right, in the world, in the ocean environment, whether that's pollution or plastics, a hot topic. And then we need to remember, of course, that there's a whole world of sound out in the ocean environment, and we have a lot of people interested in exploring that as a topic. So changing gears, we alluded to remote sensing earlier. A little commentary there, you see sort of a hierarchy of imagery from a classic, fairly expensive, complex remote sensing system satellite to some CubeSats to sort of a powerful little graphic representing artificial intelligence. And so this is an area where, because we have been putting satellites in space and looking back at our own planet and thus our own ocean for many, many years, we've learned a lot. And we understand the need for calibration and in situ qualification of data. And we're also here, perhaps best poised to capture the power of artificial intelligence and machine learning due to the sheer volume of data that remote sensing systems produce. And again, we see this focus on biological interest. And we're also interested in starting to use these systems that are typically large and macro viewed, and can we start to dive in a little bit and develop views of smaller scale phenomena. Improved observations. Well, isn't that obvious? We'd all like to improve our observations. However, as generic as that sounds, there's certainly some themes we saw in there. We saw this idea of cables and bottom sensing and better integration of global and coastal. Sea level rise is certainly a topic we saw addressed in these white papers and of strong interest. And my sort of favorite here, right, is we're all becoming powerfully aware of the power of imagery, right? Facial recognition in particular, right? So if you're following those dynamics in other industries. And so while it wasn't a massive topic, the idea of how we can use all of those techniques of optical systems and image recognition and contribute to our ocean observing through cameras also came up. Come on, there we go. Platforms, if we're going to observe the ocean, we probably should be in and about the ocean. Many interesting discussions here. Thanks, by the way, all of those photos are from folks who are exhibiting down on the floor. Appreciate your sharing those. So the drive here, though, is to low cost. And low cost essentially becomes a proxy for availability, which leads to this idea of ubiquitous platforms, so that we can see measurements everywhere we want them, and perhaps even in places we didn't know we need them. Certainly a driving theme throughout. Commentary here, STEM, education and outreach, all of these technologies draw upon that. It did come up in the robotics domain, perhaps more than some of the other areas, but next generation of technologists is a key issue. So apologies for just dropping a whole bunch of words on you. The takeaway from this slide is all the other topics that we are covering here at Ocean Obs, from the collaboration, from integration, data, information, governance. We are here as a community to figure out how to do this in the best and most effective way. Those themes also were found throughout those white papers that we binned into innovation. So an acknowledgement that this is not a topic that stands on its own. It is a topic that fits within the entirety of the system. So hopefully that gives you a little bit of flavor of the white papers. And with that, we're going to do the tag up again and carry on with the program. Juanina.
So Justin and I sort of looked at that synthesis, and again, we thank all the authors that have contributed to that. We put together this list here of things that we would like to expand on over the next few days. So this is our challenge to you. We've put up some ideas around creating a culture of innovation. How do we create a culture of innovation? We want you to think about that over this afternoon's breakouts, through all the conversations today. What are the economic drivers that we can use to scale ocean observing systems and technologies? Another topic to expand on is translating data and observations into products and services. This is a key one for me. You know, data for the sake of data is not enough. Expanding the data tools for stakeholders and access to our data products. Developing value propositions for all stakeholders. Inspiring future ocean observers. We have a great speaker, Riley Hathaway, in our panel this afternoon, who's training the next generation of young ocean observers, so make sure you're there for that. Harnessing the scaling powers of modern technology. This is a real opportunity for us. Dramatically growing stakeholder engagement. And what are the moonshot visions for the next 10 years? So these are the topics that we think we could expand on today. What we'd like to do is have a little bit of audience participation. We have a Slido poll, surprise, surprise. So we can bring that up, please. So if you go to your app and you click on the main room, there should be a poll there, and you can pick 1, 2, or 3 of these topics that you think are really important or that you would like to expand on. Is it coming up? Okay, so the poll is up. Oh, it's on the screen, fantastic. We've got 11 people already. Inspiring future ocean observers takes the lead. Oh, moonshot visions. Translating data and observations into products and services, 44%. We've only got 22 voters. Look at all these people in the room. You can get on your laptop, you can get on your phone, you can probably even do it on your watch.
There will be no coffee until we get to 100.
Justin's mic is off, but he said no coffee till we get to 100. Translating data and observations into products and services leads, still 51%. Moonshot visions, dramatically growing stakeholder engagement. Inspiring future ocean observers was there, it's back down. Keep going, 100. Creating a culture of innovation isn't featuring very highly.
I think you're biasing. There's a selection bias going on here.
I did not write the software, but my favourite one is up there, translating data and observations into products and services. 202 people have voted. This is great. Almost the same number as Ocean Obs 09.
No,
99, I'm sorry. Okay, so translating data and observations into products and services clearly leads. With a lead that far ahead, I don't think another 300 votes are going to make much difference. So we're going to leave that open through the day, and we'll come back to it, and I think tomorrow during our report out of the day, we'll show those final results. But thank you for having a look at that. All right, so that sort of concludes the wrap-up of the white papers, hopefully sets the tone for what we're about to hear today. And without further ado, I'd like to introduce our first speaker. So we have a great round of speakers today. And our first speaker is Dr. Wendy Watson-Wright. Dr. Watson-Wright is the Chief Executive Officer of the Ocean Frontier Institute. The Ocean Frontier Institute houses the Atlantic node of the Canadian Integrated Ocean Observing System. Dr. Watson-Wright has served as the Executive Secretary and Assistant Director General of the IOC, and has served on several international boards, particularly in the area of ocean observing. So please welcome to the mic, Dr. Wendy Watson-Wright.
The big green button is slide forward.
Okay, and it's going to work, right? But you have to help me here. Oh, great. Well, thank you so much for your kind words and for the invitation to be here. And good morning, everyone. Aloha. It's lovely to be here. I'd like to first say that I am not a technical expert, so I will not be talking today about specific innovations in the technology itself. Rather, my views are based on the fact that I've had many years in ocean science management, largely at Fisheries and Oceans Canada, but also, as mentioned, at the IOC of UNESCO, and now as the CEO of the Ocean Frontier Institute. And incidentally, I am pleased to say that OFI's scientific director, Dr. Anya Waite, is here at the conference somewhere. And I don't know if she's in the room, but she's here. So in my various career roles, I have seen firsthand the challenges of meeting the needs of multiple and disparate producers and users of data. But I'd like to start with a 30-second overview of what we do at OFI. As an international hub, OFI brings together researchers and institutes from both sides of the Atlantic to explore the potential of and to understand the changing ocean. At OFI, we harness the transdisciplinary talents of our researchers and partners to focus on both ocean changes and ocean solutions. I can see that font translated back into what I didn't want it to, but that's okay. Now, OFI is an historic partnership among 3 prestigious universities on Canada's East Coast: Dalhousie University in Nova Scotia, Memorial University of Newfoundland, and the University of Prince Edward Island. In addition, we collaborate with federal and provincial government departments, numerous industry partners, and 8 international institutes in 5 other countries, which you can see here, those being Ireland, Norway, Germany, France, and the US. And I'll return to our collaboration mandate a little bit later to discuss how it fits into today's topic. But first, I'd like to say a few words about those things I see as inhibiting innovation in our ocean observing enterprise, and they have little to do with technology per se. So at the risk of stating the obvious, when we talk about spurring innovation, we're really talking about 3 distinct entities: observing technologies, products, and user services. When you have multiple players carrying out different functions, their perspectives and priorities may not only be different, but in some cases may be at odds with each other. As a result, there are often understandably fragmented and conflicting agendas. The truth of the matter is that academics, funders, technical developers, and end users are seldom on the same page. And they don't always speak the same language. As often as not, they work inside their own interest silos, rarely talking to each other except at conferences like this one. And there's frequently a lack of communication among the parties and a lack of recognition of each partner's strengths or needs. In short, those who develop technology aren't necessarily connected to those interested in using the data that it produces. So this is a problem, because people want to see their own knowledge, experience, and needs reflected in the technologies we expect them to use. I believe we should reward activities that encourage joint partnerships among the 3 groups so that ideas are fully realized and developed to each and everyone's satisfaction. And in fact, I think that funding should be contingent upon the formation of such partnerships, as it is in OFI. Now, another factor is in the disconnect between parties is the hesitancy to share data. And I recognize the desire by companies to protect what they consider proprietary data. But for far too many players, the path of least resistance is to call everything proprietary and to share nothing. It's just easier that way. Other disconnects stem from a lack of diversity and inclusivity in our ocean observing enterprise. Now, meaningful collaboration means more people from more backgrounds to be brought into the dialogue. And I understand you had a very good session on this the other night. We have to recognize the value of citizen science and get away from the notion that only university-trained scientists can add to a productive debate. Now, don't get me wrong. Of course, we know that physics is physics, chemistry is chemistry, and we can't get away from the value of pure science. But it would be foolish to reject out of hand the benefit of anecdotal evidence witnessed by local and indigenous communities as they watch their coastal neighborhoods being threatened by sea level rise, polluted waters, and disappearing fish stocks. The trick is finding a common language of evidence that all parties can live with. It's a delicate balancing act between competing values and systems. And there are broader and longer term issues that also must be addressed. The first is the matter of gender equity. Although more and more young women are enrolled in biological studies, we have to incentivize them to enter other STEM programs and to get into ocean studies, and in particular, ocean observation. We also need to get youth on board with ocean literacy programs, starting at a very young age. Building the appetite to be ocean literate is a crucial part of the equation. Now, none of what I have said is revolutionary. Many of the organizations you deal with are already addressing these issues and shortcomings. But the good news is there is much being done to make the system more collaborative, especially on the national and international stages. For example, I know that most of you are aware of the work of POGO, the Partnership on the Observation of the Global Ocean. Since 1999, it has served as a forum for leaders of major oceanographic institutions around the world, and I'm pleased to note that it was started at the Bedford Institute of Oceanography in Nova Scotia. I really like the slogan of POGO, taking the pulse of the global ocean, which just about sums up the mandate. And POGO, of course, works closely with other international and regional programs and organizations, including the Ocean Frontier Institute, who joined this year, as did Ocean Networks Canada. And in Canada, I am happy to say, as noted, that we have finally joined the broader GOOSE community and recently launched the Canadian Integrated Ocean Observing System, CIOOS, which I prefer to call Canada Goose. I tried, but they didn't listen. OFI is hosting the Atlantic node of Canada Goose. And that leads me to expand a little more about what we do at OFI, especially from a collaborative perspective, and which speaks to some of the challenges that I've mentioned. Now, everything we do falls within 4 areas: research, people, both training and exchange, infrastructure sharing, and knowledge mobilization. And I'll speak to the first and the last there. It is our ocean research that serves as OFI's foundation, and it focuses on understanding ocean changes and the implications not just for the ecosystem itself, but for the economy and for our communities. And to that end, we have numerous large research modules in play. So I'd like to mention just one that deals with ocean observations in the North Atlantic. A US-led international research team from 7 countries, which included senior OFI scientist Brad DeYoung, conducted an extensive multi-year study into the critical role the Atlantic Ocean plays in regulating the Earth's climate. Their goal was to measure the deep circulation in the northern part of Atlantic from Newfoundland and Labrador to Greenland, and from there to Europe. This circulation, as mentioned and as you know, is a key component of the global ocean climate transport system. But their surprising results indicated that most of the heat and mass transport was on the eastern side of the Atlantic. Very little total transport came out of the Labrador Sea. Now, this research is critical because the deep circulation of the ocean, of course, is a key regulator of the global climate system. And there have been several predictions over the past couple of decades suggesting that the circulation is slowing because of human influences. If this circulation slows, as predicted, it would have an enormous impact on both the climate and weather of Eastern North America and Western Europe. So armed with this new insight, the team of researchers will continue to monitor the deep ocean to try and figure out what's happening in the Labrador Sea in the winter, as well as to look at freshwater transport on the western side of the basin, which is a new line of inquiry. I'd like to switch gears now to another part of our mandate, knowledge mobilization, which can take a number of forms, and 2 quick examples. On the industry side, I mentioned we have numerous private sector companies as partners. The Center for Ocean Ventures and Entrepreneurship, or COVE, is a private sector-led R&D collaborative facility in an old Coast Guard base on the Halifax Harbor that brings various ocean sectors together to boost innovation and modernization in Canada's ocean industries. It is a space that cross-pollinates expertise, ideas, and resources among tenants, and a community that brings together the best and the brightest to push ocean tech advances to market, and it does include scientists and technicians. So OFI and COVE work very closely to bring together researchers with industry at the beginning of projects. In a similar vein, OFI is a member of the Ocean Supercluster, which is a fairly new $300 million industry-led R&D collaboration that brings companies together to boost innovation and modernization in Canada's ocean industries. The ambition of the Supercluster is to grow Canada's ocean economy from 20 to 30 billion Canadian by the year 2050. And our scientific director, Anya, is on the board of directors of the Supercluster. On yet another front, we're working to advance ocean literacy among our young people. But instead of talking about it, I'd like to show you this short video clip of this partnership between OFI, Dalhousie University, and the National Film Board of Canada. And I hope this works.
Hi, my name is Boris Worm. I'm a professor of marine biology at Dalhousie University in Halifax, and I'm the scientific director of Ocean School. Yeah, I've been an ocean scientist for about 25 years, traveling around the world, documenting ocean change. What I see concerns me, but at the same time I feel we're at a crossroads where now we have the tools, the data, the knowledge to really make a difference and come up with solutions that work in bringing about more sustainable development for coastal communities and coastal nations around the world.
Let's dive into Ocean School. Ocean School is a free online educational experience designed to help you better understand your impact on the ocean and the ocean's impact on you. Join our youth hosts as they work with inspiring scientists and experts to discover how each of us can help shape a healthy ocean. Ocean School is filled with great stories, told through immersive video and interactive experiences. Explore ecosystems and habitats, drive an underwater robot, or even dissect a virtual cod. Each piece of media is linked to a customizable activity designed to deepen learning. Are you a lifelong explorer? Just sign in and you're off to sea. Are you an educator? Start by discovering our content. Then visit the educator space, create your Ocean School class, and explore our help center. Built with inquiry in mind, Ocean School integrates with Google Classroom. Your students will navigate through the content, seeking information in order to put their learning into action. Whether you're an educator or a lifelong explorer, there's a lot to discover in Ocean School.
So we're pretty excited about Ocean School, and I'm very excited. We just learned this week it's been nominated for the Japan Prize for Digital Media. And I will say that ocean literacy will be a big part of the UN Ocean Decade of Ocean Science. And in that light, I'm happy to say that the Ocean Frontier Institute will co-host the North Atlantic Regional Workshop for the decade from January the 7th till 10th in Halifax, Nova Scotia. So stay tuned. So it's time for me to wrap up. In the final analysis, spurring innovation and observing modalities is not simply a matter of throwing more money at the technology end. Rather, it is much more of a human issue, and we've heard that referenced earlier. The questions we need to ask ourselves include, does the technology we're bringing on stream adequately serve the needs of users? What are the tools we can use where we take the content of well-done science and make it a part of a dialogue of and for non-scientists? In the same vein, how do we blend the traditional way of doing things with new understanding of what non-traditional sources bring to the table? Which leads to the broader question of how do we integrate different knowledge systems on a larger scale? Are we making ocean observing in all its forms more attractive for heretofore neglected groups? That includes making it more attractive to young people, especially young women, and of course, Indigenous groups. So in short, are we embracing diversity in all its forms? I believe that the better we answer these questions and act on those answers, the closer we get to spurring innovation in ocean observing. Thank you, and I look forward to the discussion.
So you may feel that Monini and I rushed through our content, and we did, and there was a reason for that. We firmly believe in interactivity, So what we're going to do here, and if I could have the table mics turned on for this next brief moment. After each plenary speaker, we're going to present one of the questions from Slido for that speaker. So as the speakers are speaking, if you're thinking about that. So at the moment, Wendy, if you'd be so kind, we'd like you to address the question and highlight there, just briefly. I think it fits with some of the things you were telling us about, but fear of failure and risk tolerance. If you could provide some comments, we'd appreciate it. Sorry for those. So the question here is that can the research community accept the risk of failure associated with innovation?
I'm not quite certain I understand the question, but I don't think that we have a choice, to be honest.
Well, feel free to react however you're most comfortable.
Well, I think as we've heard, there are so many different definitions of innovation, I think, but here it's for ocean observing. My question throughout all of this is not so much about products and services and translation, it is this so what? And how are we going to convince the powers that be, those that actually do the funding, to understand that ocean observation or ocean surveillance is equally or more important than weather surveillance? I mean, they go together. So we have failed in that, and we've looked for terms like operational oceanography and all kinds of other things, but we really haven't captured the imagination, I would say, of the politicians at the right time in the right place. And so I do think that there has to be a concerted effort to do that, recognizing that the expertise that's in this room has to contribute, but we have to move it up a few notches.
Thank you. We'll do this again after each speaker, and then there'll be a much wider ranging Q&A. So we'll move on now with our program. It gives me great pleasure to introduce Dr. Marlon Lewis. Marlon happens to also come to us from the same part of the world as Wendy, but is bringing a different perspective. Marlon is an entrepreneur and a scientist, created Satlantic Instruments. I'm sure many of you in the room have used that equipment, has been highly awarded from ASLO and NASA and the Oceanography Society. And we asked Marlon to come here and share some thoughts about how the science and the technology of ocean observing might need to be challenged a little bit. So with that, I'm pleased to introduce Marlon. Take the stage here, and we'll do another question again at the end.
Okay.
Big green button.
Thank you. Thank you very much. As we've heard over and over again this week, our ocean is facing a myriad of challenges that will impact over the future. Some of these are, in my opinion, not particularly serious, like plastics in a relative sense. Others, on the other hand, are existential in nature. One of the examples of the latter is the accumulation of heat in the global ocean. This is a graph that was presented on the first morning here by Sarah Posset there, and I reproduce it here. There. For those of you that may not have a visceral feeling for what a zettajoule is there on the y-axis there, or perhaps as they say in the United States, a zeta joule there, I've tried to translate that in the y-axis to something that might have a little bit more feeling for those of you that are children of the Cold War. And it's a remarkable number to me, and I was astonished when I first saw this and have reproduced the calculation over and over again because I just couldn't convince myself that it was true. But the heat that has accumulated in our ocean here over the last 25 years amounts to the release of energy from 5 Hiroshima-class nuclear explosions every second. And that, if it doesn't keep you up at night, may drive you into a duck and cover there in the Cold War analogy there. But that's only half of the story associated with this particular plot there. And the other is, as Sarah pointed out, is the collapse of the uncertainty about this data here as we go forward in time and as the amplitude increases. That's quite different from most of the geophysical variables where the uncertainty generally increases as a function of the amplitude. And here it's actually decreasing. And that decrease has everything to do with the improved observational base that's been afforded by the Argo sampling network. So in terms of trying to estimate the present and particularly the future state of the ocean, I don't think we need to take any arguments here for this part of the talk anyway, that what are required are observations, many of them, all over the global ocean, including the coastal regions, and they must be very, very accurate, and they need to be in place for centuries. And that's an enormous challenge for us to face. It's the reason why we have this conference here today. We need as well as the observations, the adequate models of the physics, the biology, the chemistry, the geophysics there, and some representation of the statistics of the signal and noise in order to produce meaningful fields. So the models and the observations go hand in hand and not independently. And I think, again, I don't think I'm going to get any argument at this point from folks that the future of oceanography to meet these requirements is in the reliance on autonomous observations of the ocean. That is from space in terms of the satellites there, in terms of the sensors that are measuring the ocean interior there. And that has been a real achievement over the last 15 or maybe a little bit longer years of this community in particular there. And we should all, the royal we, should be justifiably proud of that. This is a little bit hard to see. This is from Steve Reiser's paper a couple of years ago. They are looking at the distributions of observations of profiles of salinity and temperature in the upper 2,000 meters here, comparing the coverage in the lower panel that's taken from the World Ocean Database over the past 100 years. There's roughly 500,000 profiles with those that are encompassed within the Argo program. And as you can see in the lower panel, there are vast regions of the oceans where the number of observations are counted in the single digits there from the traditional observations. When we launched a mission to the South Pacific Gyre about, well, it's now been 15 years ago or so, in looking and sort of preparing for the cruise there, looked at the database and realized that there were a sum total of 9 CTD casts in the entire South Pacific Gyre that were existing. And that situation has thankfully resolved itself, and we're at a point now where in terms of the physical temperature and salinity, sound speed profiles of the upper ocean there, the Argo has exceeded our previous measurements by a factor of 3. Our BGC, or biogeochemical Argo community, is catching up quickly, I would say. This is data that's assembled by Katja Fennel and her team. It's down on her poster down below, and you can have a look at that, where we're looking at the accumulated data points for profiles of chlorophyll on the left-hand side and of nitrate on the right-hand side. And as you can see, the mustard color there are bottle casts from the World Ocean Database, the brown, maroon, red, whatever it is, from CTD, from fluorometers on CTDs, and the blue is from the BGC Argo floats that have been in existence. And you can see they're catching up quickly. It's almost an equal point, not the same level as the temperature and salinity, but getting there quickly. Nitrate is even more remarkable there. This is the SUNA sensor that I've had some involvement in with Ken Johnson there. It's rapidly becoming the predominant data source for nitrate concentrations in the world's ocean. So things are catching up quickly. So I think we have every reason to pat ourselves a little bit on the back. However, I would submit, and this is the part where I think I'll probably get some disagreement from the audience, that before we get too complacent there, the point is that the ocean, I believe, is still severely undersampled, and that we're going to need a new model in order to move the needle a little bit more than what we have already. For example, and this is, again, I'm sure you'll take issue with this, with the current Argo fleet of 4,000 there, if you just do a rough calculation, it works out to be approximately one profile every 90,000 square kilometers every 10 days over the entire global ocean. Now, there are many places where it's much better than that, obviously, but in an average sense, we are resolving with the Argo program an area that would be, or a resolution that's roughly the size of Maine or Portugal. They're roughly 3 degrees by 3 degrees there on a global ocean there. I would like to contrast that with another experience I had when I used to work for NASA headquarters for the Ocean Color program. We had a lot of discussions in the design and development of the CWIF's Ocean Color sensor, and as well the MODIS Ocean Color sensor and sea surface temperature, about what would be the minimum acceptable resolution for these satellite sensors, because the finer their resolution, obviously, the higher their cost, the bigger the telescopes, and so on there. And the community came to a consensus that nothing else would be acceptable except for a global resolution at 1 kilometer, so that one could build up composite images there that resolved scales of sort of 10 square kilometers every 10 days. So if you look at these two, between the Argo fleet, the resolution, and the satellite fleet, there you see quite different answers there. And for some problem, for many problems, not all, absolutely not all, but for many problems, we would like to have observations of the ocean interior on scales similar to those measured at the surface by satellite. And some of the talks here have emphasized that, the one in particular by Dr. Liu regarding the meso and submesoscale variability of the ocean and its dominance in heat transport certainly would fall into this category. Likewise, some of the arguments made for better predictability of the ocean would as well. So this would imply an increase in the observational capacity at present by a factor of 1,000 or more there. And at the present time, with current technologies, this is prohibitive in cost. So I would like to think a little bit about how do we move beyond this? And I would propose that our current approaches to development of sensors and platforms and data systems and the whole 9 yards there does not lend itself well to scaling up here, and that we need to step back a little bit and think, how can we develop a system collectively that would in fact scale to a factor of 1,000 to meet this? And I'm a firm believer in 1 over the square root of n, as you can see there. Yeah. So we need, in my view, a new model. Now, I would submit, and again, this is a little bit of hyperbole, so my friends in the sensor development business, I'll probably have to buy you a beer here, but I would submit that the way we build oceanographic instruments and sensors right now resembles a very artisanal approach to things, sort of a craft beer approach. We build wonderful sensors with incredible precision and accuracy there, but we build them sort of as a one-off and very custom. They are developed for specific applications there. They don't scale well. I don't think that we'll be able to continue to run an artisanal operation of this sort to a world of 1 million sensors. We need to look much more toward scaling this in a way that would involve economies of scale in terms of sort of fab plants that will produce them with the absence of a lot of handwork on each one of our pieces to be able to reproduce in a consistent and reliable way sensors that would allow us to reach these scales. And I owe a lot of this thinking to friends Mark Abbott in particular, Ken Johnson, Jim Bellingham here. In sort of our wilder moments, we envision sort of these autonomous vessels sailing the ocean that are fab plants that are producing these sensors and spewing them out as they go along there. They're very much different than the approach that we take today. It's a technical and a market challenge for sure, with the deployed fleet of 1 million there and a sort of a three-year lifespan. We might need to replace them with about 350,000 per year. And this is the point, if we could make the unit cost of order $300, the annual cost would be about 100 million. It's not totally crazy. The challenge is, the tech challenge is, and this one is for Ken Johnson. You know, in the old tradition of naming dimensionless numbers, I'd like to just name the ratio of the selling price of an instrument to the parts cost. Almost across a whole lot of instruments, it turns out to be pi. So if you, if you buy an instrument for $10, the parts costs are roughly $3.14 that goes into that. If we follow that, the Johnson number approach there, that would represent about $100 in parts, which is not all that unreasonable there. The iPhone, in fact, works out to about a pi times the parts cost, for example. So there's a technology challenge for sure. There's a market challenge that's a chicken and an egg. No company is going to invest in the development of a, and the NRE needed without a committed customer, and no committed customer is going to be crazy enough to plunk down that amount of money in the absence of a proven solution. So we've got some things to work around there. The one other challenge that I didn't write down would be there's a social challenge for our community here. I have spent much of my life building cool shit and taking it to sea to make measurements, and I like to think that that's going to be something that'll be possible in the future, but I think that in the future we're going to need to look a little bit beyond that and more of the model of the remote sensing community, that the building and the deployment and the operations and perhaps even the data system will be outsourced to private companies, and they provide the data to our community for analysis and interpretation and prediction there. And that's going to be a big disruptive change to our research institutions, but I think it's one that I can already see lots of signs of happening already. So in conclusion there, the detection and quantification of changes to the global ocean reservoirs of heat, carbon, nitrogen, et cetera, there requires an extensive, consistent, and accurate observational base coupled with advanced models. It's an exceptionally hard problem. The changes that we're looking at are very, very small relative to the size of the reservoir, but of immense concern. The use of robotic droids is really the only reasonable way of approaching this. They complement satellite observations and provide that third dimension and in the presence of clouds. The future is uncertain. For sure there's going to be new technologies, but I think in order to achieve what we'd like to do, I think we need to step back and think, how do we scale this up? Scale it up in the same way that, for example, Planet Labs has done with the CubeSats that Justin Handley talked about earlier. And with that, I think we've had a lot of challenges ourselves, and I thank you very much.
Thanks, Marlon. That was excellent to get you guys thinking and start some discussion. If we could get the Slido questions up, please. So you see there's a couple there right at the top that have got some lots of votes, which is great, and it's really great to see the interaction coming in, so thank you. The first question there from Sean Smith: as a community, should we be concerned with innovating platforms and sensors that are recoverable as opposed to contributing to the marine debris problem? I'd like to put that one on hold. We have a great panel this afternoon, or just after the coffee break. You have to come back for that panel because we have Tim Jansen, CEO of So Far Ocean, who's an evangelist for distributed float networks. And we also have Roger Hine, co-inventor of the Wave Glider. So both these people are going to address that question, I promise you. So come back for that one. And then the second one, can we move towards unsupervised systems instead of calling them unmanned? I'd like to address that one as well. I think it's good to have a debate. So some suggestions have been unmanned, instead of unmanned, unpiloted, uncrewed, unaccompanied, and unsupervised. I just want to put it out there that those words resonate with 50% of the population, I guess. So we should come back, we should address that as a community as well. But as for a question that we're going to actually ask you, we're going to go to number 3 on the list, which is... The list keeps changing. The Jose Molbert question. Is OceanObs ready for the next advances in AI and data cloud? It's not there. Oh, I can. There we go.
Yes, that's an excellent question there, and I think that, no, we're not ready for it yet. It's a very, very active area of research there, but it's one where the scale will not only spur that on, but also benefit from it there. I think having the ability to scale our observing system up to the levels that I was speaking about here provides a means by which we could apply some of these advanced tools for doing sort of pattern recognition and analysis and generating new services or whatever you will there from such a database. And so yes, I think it's a great question. I think it's the natural complement for the future.
All right, thank you. So, and we will have an opportunity for more questions right at the end. So keep them coming and keep voting on them, okay? So our next speaker is Dr. Jyotika Vermani. She's the Executive Director of Planet and Environment at X Prize and the Executive Director of the Shell Ocean Discovery X Prize to incentivize deep sea technology to map the seafloor rapidly, accurately, and at high resolution. That sounds fantastic. Before joining X Prize, she served as Associate Director of the Florida Institute of Oceanography and a Senior Scientist at the UK Met Office. We're thrilled to have you today, so please welcome Jyotika to the mic.
Thank you. Thank you. Aloha. As I was introduced, I am the Executive Director for Planet and Environment at X Prize, which is the best job title one is ever going to hold. Step up from there is, of course, Supreme Ruler of the Solar System. So hence this image, which looks at my domain from outside. I want to step back to around 150,000 years ago. We as humans have evolved in a very local and linear world. We knew maybe 150 people. You walked everywhere, so maybe 15 miles were covered. But this has all changed. This has all changed only in the last 100 or so years. We now live in an exponential and globally connected planet. We can fly long distances. I bet you everyone who's got on social media has more than 150 friends on social media alone. And we're now in a room of 1,500 people, which in the old days would be a war zone, basically. And here we are to collaborate and move forward. So the world has changed, but not only has it changed, it's changing exponentially fast. So what does that mean? So if you take 30 linear paces, you travel 30 meters. However, if you take 30 exponential paces, where each step is a doubling of the one before, you actually travel 26 times around the world. And that's a huge concept to grasp, is that's how fast our rate of change of technology is moving as well. So I've got a couple of examples. Looking at data storage, what does that mean for exponential growth? So data storage back in the 1950s, you see the black and white photo there, it would take a forklift to load a device that could store 5 megabytes of data onto a plane. It would cost $120,000. This is just over 50, 60 years ago, right? By the way, that image, you could store 6 of those images on that device, and that's it. Move forward to 2005, where you could get a 128 megabyte storage device for $99. 2016, 128 gigabytes for $40. Now we're looking at terabytes. You can go and buy terabytes of data for just tens of dollars. So this is an exponential rate of data storage. Let's look at computing. Right now, your average laptop works at around 10 to the 11 calculations per second. So that's the speed of a mouse's brain. So looking at this logarithmic plot, what we're looking at is in the next 10, 15 years, we will be carrying around devices that can operate at 10 to the 16 calculations per second, which is a human brain, which means that as we look forward to the next decade, we should factor in this faster and faster speed of being able to do computations. And then beyond that, another 25 years, and the estimate is that our laptops will operate at the speed of all the human brains on the planet. So that's exponential growth, and we need to plan for that in the next decade. If we don't take these technology trends into account now, ocean observing is going to be so far behind the trend. So that some of the exponential technologies, of course, we do have sensors, and we've seen some rapid evolution in sensor technology. eDNA is a nice example for the ocean world. We have artificial intelligence, robotics, synthetic biology, virtual reality, which, by the way, is actually old now because we're starting augmented reality and 3D printing. And these have evolved rapidly and are hitting the mainstream media as well as the public eye every day and have been in the last 4 or 5 years. So what do we do at X Prize? We run competitions, prizes, to pull these exponential technologies into various arenas, whether that be in space, in medicine, in education, or in the environment domains. And we do that because this is a way of spurring and speeding forward innovation and producing prototypes of various technologies. And I want to just touch a moment on what's the difference between prizes and grants. And this was kind of addresses the first question that was asked this morning. So in both cases, we define the problem, we develop a criteria, an evaluation criteria, and we announce a grant or we launch a prize. But then it starts to differ. For a grant, you look at who is applying, so you find the right workers, they've got a proven track record, and you award the grant, and then the work starts, and the monitoring effort begins, and you pray for success, and it's okay if it's not successful because you've still proven something, and you then redefine the problem, and you go again. For prizes, the solvers self-select. They self-fund their efforts. We test and evaluate the submissions, and then we pay the successful ones. But it's not just the winning teams. What we've done in that process is tested a number of different prototype solutions. And we see that actually, I've seen a number of our Ocean Health, our Wendy Schmidt Ocean Health former teams here at this conference with some of their further solutions. So collectively, we then work on the impact. So that's the difference. So both methods include and propagate innovation, but not necessarily both are for everyone. So X Prize has awarded $70 million in competitions already. We have an active $36 million in, as I said, environment, education. What I want to touch upon in a little while is the AI and the Avatar X Prize. But I'm just going to take a step back to the one that we just awarded in May, the Shell Ocean Discovery X Prize, which was for unsupervised technology to map the seafloor at a very high resolution and very quickly. And here is a portion of the winning team's entry. This is an unsupervised surface vessel which can deploy and recover an AUV, Kongsberg AUV, with no one at sea. So it's all done from the coastline. But not only has this proven, and we've tested it, to map the seafloor quickly and at high resolution. And by the way, our criteria was to measure at 5-meter or higher resolution within 24 hours. They have gone on to do the first unmanned surface cargo crossing of the North Sea, where they took oysters from the UK to Belgium and brought Belgian beer back. So we're now seeing a wave of a different way of operating in the ocean, which is safer, it costs less in terms of fuel, and it brings that autonomy into the ocean and on the surface. So let me talk about the IBM Watson Artificial Intelligence X Prize. So we've all heard the term artificial intelligence. This competition was to look at AI for good. What are the various ways that artificial intelligence can be looked for good? And I looked through the teams that entered this, and there's, improving beekeeping. There's actually an AI for trash, so you can throw all your rubbish in one bin, and it will decide what's recyclable and what's not. There's a number of medical artificial intelligence technologies under development, including analyzing CT and MRI scans, identifying new drugs. There's a number for educational artificial intelligence teams in here. Mosquito control in the sub-Saharan Africa. What I didn't see was anything in the oceans. And there's a disconnect here because this is the artificial intelligence community. I gave a talk at the United Nations earlier this year at the AI for Good Summit at the ITU. And there was one small session on oceans in a multi-day artificial intelligence global event. So I think we need to really engage with that community. Our expertise is knowing about ocean observing, knowing the science. Their expertise is artificial intelligence development. Let's meet and let's get this on the road. Here's an example. So Microsoft has an AI for Earth program. They give out grants. They are working in various fields to push and promote AI for good. And we, collaborate with them. In their number of grants that they have online, there's one on the ocean, and that's using artificial intelligence for illegal fishing. So to have AI tell authorities when a ship is acting abnormally. Instead of having humans look at that. And then authorities can go in and act on that. The Avatar X Prize, though, is a step beyond that. So by the way, we're in a technical revolution, which of course everyone knows. The third step of that was computing and automation. We're now approaching the fourth stage of that, which is cyber systems and our integration with cyber systems. So this is integrating robotics, telepresence, artificial intelligence, advanced sensors, haptics, brain-computer interfaces, virtual reality, and augmented reality. And the idea here is to build an avatar system, which is a robot, and you as an expert or a person put on a haptic suit that will allow you to sense everything, see, smell, hear, touch, the works. And the robot can be in a remote location. So if in the future there is something like a Fukushima, you would send in the avatars, but it would be controlled by the experts to shut things down. So that's an avatar system. And these are under development. This image is from the Toyota Research Institute. And this prize, by the way, we're closing team registration at the end of this month. So if anyone there has any thoughts and wants to enter, please do. But what we're looking at in the future, and this is happening now, this will be awarded in the next 3 years. We're looking at potentially avatars in the ocean. So this is now a completely different way of accessing the ocean, where instead of having a human diver that's limited by the tank that they have, we can actually control that from shore remotely and have an avatar underwater instead. And this, by the way, is from the Stanford Robotics Lab, this image, it's a tethered robot. So that's the Avatar X Prize. So moving forward for X Prize, we have a coral restoration X Prize that we've done the prize design for, that we're now seeking funding. Can we use technology to rapidly restore corals? We have an Amazon Rainforest X Prize. This is about biodiversity. Can we use technology to get an accounting of what's in the Amazon rainforest and, by extension, other rainforests around the world? We have others in the environment domain, the planet environment domain, zero waste mining, wildfire detection and extinction, which are all prizes under development. So there's a lot of areas to move forward on, but I really encourage this community to look to the future and to look outside and see what's going on in the technical realm. Thank you. Mahola.
Thank you, Jyotika. A quick administrative comment. So in case you haven't noticed, Monini and I keep leaning over and looking at my iPad, and we're checking in on Slido. And an observation, there are a lot of really interesting questions if you scroll down. And the questions that have been voted up, there's sort of a selection thing going on. So please do scroll around as you cast your votes. I'm going to start that process by asking Jyotika a question. Here's where we are in the lay of the land. We're going to take about 25 minutes for Q&A. We're going to use Slido. We can use the microphones. And then we will have a special announcement from some colleagues who have some interesting things to share with us. So that's what's going on now, and I'm going to start. The question I'm going to present, Jyotika, is not high on the list there. It's down low. And the question, Jyotika, if I could ask you to get started on, is can you express perhaps a vision for how an Internet of Things concept might engage and contribute to the OceanObs community? And then we'll sit down, and if the panel mics can be turned on, we'll take everything here from the table then. So Jyotika, if you could answer that one first, please.
Okay, well, that's a tough one. Yeah, I'm not an expert on this. I just talk about it. No. So an Internet of Things is where everything is connected, and we can just basically monitor things from afar. So let's take, off the top of my head, let's go back to the surface vessel that I showed, the unmanned, unsupervised surface vessel. Right now, I mean, I saw that the mission control and the bank of computers and people monitoring and coordinating and deploying and recovering an AUV. What they were also able to do was to not only go by a preordained track, but when they found something of interest or they wanted to go back, they had the flexibility of controlling the surface and the subsurface device and going back and doing things much more quickly. Now, what I can see with that is that we actually have that connected to other sensors, so that if you see other things of interest as you are out there doing these operations, that you can then go back and do that. So I don't know if that fully answers the question, but I think we can see a lot of sensor technology that can be integrated to go back and investigate, I don't know, a seamount that you've just discovered, because it's very expensive to keep going back and forth. So I'm sorry if that doesn't answer the question, but there's a vision there of integration.
And so, Jyotika, I appreciate those insights, and would invite Marlon and Wendy. Marlon, to start, we'll just go down the line. If this topic of Internet of Things connected to ocean observing, if you have some ideas and remarks you'd like to share, we'd certainly invite them.
Well, it's kind of a buzzword for an awful lot of sensors that are out there taking measurements, so I would say it's entirely consistent with sort of my view of where we need to be going there, and the parts that tie it together in terms of the wonderful question about the AI before are going to assist not only in the design of such a system, but in the application and use of the system after it's deployed.
Okay.
I think, oh, there we go. Sorry, so as Marlon was talking, I had another thought. So right now we're at that prototype stage where we have to have banks of computers to do these operations. But the Internet of Things is you could actually control it from your phone in the future. So you could be here at a conference, but also be looking, during the break at what is going on out at sea. So I think that that's the next step maybe, is to make it mobile so that we can move with that kind of technology at our fingertips.
Thanks. Good.
So if we can get the Slido back on the screen. There's a question here that says, innovation should be inspired by requirements, e.g. the roadblocks to uptake by applications, transformation models for innovative measurements into models. Neville, what's your question? Would anyone like to comment on his statements?
Yes.
All right then. Okay. Would you like to comment?
Deeper thoughts?
No. Yeah. I agree with it.
Yeah, I do too. I would like to ask about the question below, though. It said, can we stop patting ourselves on the back? And I'm not sure what we're patting ourselves on the back. I sincerely don't understand what... Are we patting ourselves on the back? I don't know that we are, or...
So so thanks, Chris. I appreciate, I think, what you're trying to get at, and I see folks standing up. We'll come to the floor in a second. I'm going to take executive privilege and recast Chris's question. I think what we're getting at here is we've spent a lot of time this morning trying to inspire people about the power of innovation and technology. Can we now, all three of you certainly, offer some ideas on how we translate and redirect and harness that power to contribute to the challenges and opportunities of this community? So great stuff has been done. More great stuff needs to be done. Can you connect those two for our audience, please?
I would love to be able to, but I think it comes back to what I said earlier. There is a disconnect, and at the end of the day, it is all about people. And it is about getting the right people interested at the right time in order to move things forward. If we had the answer to that, I think that we would have done it before. I like the moonshot vision idea, you know, the NASA vision, and NASA, they did it well. The space people did it well, so I think we as ocean people could take lessons from that, but you know, it's the right people at the right time, and it is at the right time. The timing is everything.
I don't think that there's any doubt that there's been incredible successes from this community here in terms of the improvement in our observation of the global ocean. We've recognized for 50 years the ocean is severely undersampled, and I think we're making some improvements here that I'd never even thought would be possible. 10 years ago, we had the beginnings of an Argo program there, and I remember questions saying, well, has anybody actually written any papers or done any science using the Argo data? And boy, men, I think we've got a lot to be proud of, and I think it's a good idea to pat ourselves on the back for that. I think that's nothing wrong with that. That doesn't mean that we should be complacent and say, okay, that's it. We're going to, have 4,000 sensors in the ocean from now and forever there. And I think we need to look beyond that and absolutely match up the requirements to the new developments there in terms of what are we going to need to do to try to adequately resolve the scales of variability in the ocean environment. Thank you.
I think actually a place where we really need to set up is to establish external partnerships. So with like I mentioned earlier, the AI community, but we're talking about how do we communicate. I was talking to Terry Quinn last night, but that's an entirely separate skill set that we don't necessarily have the ability or time to tap into, but there are experts who do, and they know how to do it. Talk to mass marketing or mass communication folks on how do we change that dialogue. For capacity building, again, we can do a number of different things. So you can do we have any, when we, as I was growing up as a graduate student, is when we started to have things like MBA and marine science courses or legal and marine science courses. Do we have a technology or an AI and marine science course anywhere for students to be versed in those up and coming fields and to train machine learning? One thing I actually forgot to mention is I was talking to my AI colleagues at XPRIZE who were talking to the AI community, and for machine learning you need a lot of data. And so a lot of areas for artificial intelligence development has limited data, so it's quite slow, whereas they're really trying hard. What I heard, though, the feedback was that the ocean community has relatively more data, but not enough of the artificial intelligence use of that data and the data integration. So I think that's an area that we should really step forward and look outside and partner with those experts. And for innovation, as a scientist, I don't do the engineering, or for business, I don't do that. I partner with people who do that. And then, as Wendy said earlier, it's not just us experts. The good ideas, and this is one of our mottos at XPRIZE, can come from absolutely anyone, anywhere.
That's a perfect lead into the next Slido question. And I promise floor people, you could probably type in your phone and have the question before we answer this one, but we'll get to you. How can we set up ocean science incubators, right, with mentorship from experienced professionals to take ideas forward and help find leverage funding? So, Wendy.
Yeah, in fact, that's happening in a few places. Halifax is one of them, where we have the Creative Destruction Lab, and they have set up an ocean stream within the Creative Destruction Lab. And in fact, it's meant to team up very successful entrepreneurs with young startups, and in this case, in particular, ocean industries. So one of the successful firms within one of the first Creative Destruction Lab competitions was one that the Ocean Frontier Institute had funded with a very small $15,000 seed fund, and they're moving on now. The proof is in the pudding, of course. It's relatively new, but there's great excitement about this of taking, seed fund recipients, getting them into this creative destruction lab, and it is a national competition. They winnow them down from across all of the centers across Canada, but we're really excited about this and about how it's working with now the Ocean Supercluster and with the Center for Ocean Ventures and Entrepreneurship.
Thanks. Marlon, Jyotika, your thoughts? No? Marlon passes. Jyotika?
No, I think Wendy covered it.
Okay, well, so we'll pop over to the floor for a moment. I see a question over there. If you could just briefly tell us where you're coming from, your name, and if you're directing to a specific panelist or to everybody. Thank you.
Yeah, so my name is Noah Lawrence. I'm from the Pacific Marine Environmental Laboratory, and there I am an engineer, so I'm basically embedded with scientists developing technology and innovations. So my question, it kind of relates to what Chris was talking about, is that I think as we look forward to how we're going to grow with innovation, it's important to also look at where we're failing currently. So this is my failure and my challenge to kind of everybody in the room. So here goes. We've seen a lot from the panelists, and in my experience, technology is exponentially increasing, right? It's just running out of control. Our possibilities for ocean science are, the existing possibilities and the future possibilities in a couple of years are just going to be huge. Where my failure is, and I feel the failure of the ocean science community is our ability to keep up with that technology. I really feel that we are too slow in our adoption. Our traditional ways of base and structure of, doing kind of integrations, running little field trials, sitting on the data for, 2 to 3 years, writing a method paper, then, talking about it more, running a couple pilot studies, and then actually getting kind of serious about implementation, 10 years down the line. We are missing out on a huge amount of opportunity there. We're talking about innovation in tech companies where that is, basically centuries of time, where we have companies that come in and they basically say, okay, we have this great idea, but before the community is really going to implement it in any time and numbers, we're talking about 10 years down the line, and they have to somehow sell that to funders, and they have to sell that to their, to the interesting and new people who are working on this technology. So I think that's a real problem, and I think it leads kind of into all these questions about why are ocean sensors so expensive and things like that. And one of my big feelings is they're so expensive because these companies basically have to pad 10 years of, selling 1 or 2 or 3 sensors before they can establish that. So my challenge...
Can you pick a question out of that list?
Yeah, no. So my challenge is to the community is how do we speed up the process of adopting the technology?
Great. And sorry, and for the panelists, it's just so you all know, there's some weird reverb. So here's what we took, right? Exponential tech is happening. That's cool. It sounds, and apologies if I'm getting this wrong, but we're in this community slow to benefit from that. So I think if I'm interpreting the question correctly, back to the panel, and if I'm not, I apologize, but how can we better leverage all the things you talked about, whether it's the ideas Marlon put forward or the exponential technology Jyotika put forward, some concrete examples to accelerate this community and make things happen faster? Is that a fair riff on your question?
Yeah, to sum it in one sentence is how can we more rapidly take advantage of this technology in the community?
Okay. So how can we more rapidly capture all of this potential we've been hearing about this morning?
So Jyotika and I have elected Marlon to answer that question.
It's a great question, and one that I struggle with a lot there, because it is, as I said, very much a chicken and an egg problem there, because no company is going to invest the kind of non-recurring engineering, at least the companies that typically work in our space here, for an uncertain payout in the end there. It's if you're building a $300 sensor, you got to sell an awful lot of them to be able to be equivalent to selling a $100,000 instrument. So that volume, that scale has to be there, and it's going to take somebody making the first step to get that NRE covered so that we can continue on going there. Maybe it's a job for X Prize.
Can I add to that?
Yeah.
Okay. Hello? Oh, great. So that's an excellent question, and it's just to build on that answer. One of the reasons that we're slow to uptake is user operability. So how easy is something to use? And I was sitting in a talk that Dawn Wright gave years and years ago, where if you build it and it's easy to use, it will be adapted faster. And an example of that is phones and apps. The easier it is to use something, people tend to latch onto it faster, and so then it's sort of like a self-fulfilling prophecy. So that's one thing I would also encourage as we go forward in innovation, is how easy is it for anyone to have a go at.
And if I could just add to what Marlon was saying about the chicken and egg, I think that comes back to this whole notion of transdisciplinarity, where actually the potential user and the innovator get together at the beginning of a project as opposed to the end to design, to figure out what is the problem and to try to design together some sort of a solution. I know that's ideal, Marlon, I know what you're going to say, but it's worth trying, and I do think that's the transdisciplinarity is really important.
And then just the final point on that is, I think one of the slides this morning had it might be the NOAA breakout session, on focusing on transition technologies and doing more on how do you transition faster. So I'm hopeful that in the next few years there's going to be some focus on that.
Thanks.
So we've got a X-Prize specific question. There are a number of them that have come through, and I'll just pass some comments here first. One comment is that self-funded effort reminds the question or statement maker of the race to the bottom with the gig economy where Uber and Lyft drivers are self-funded. And I guess this person isn't so keen on that model. There's another statement around demographics of people who are applying. Mm-hmm. You know, are we perhaps limiting people, their participation? So if you might like to comment on that.
Absolutely. Yeah, so that's something that I get asked every so often. So we are kind of like the Olympics and the Olympic Committee. We actually run the competition. So you wouldn't expect the Olympics to fund every athlete from every country to participate, to train and participate. That is up to the country in that case. So for X Prize, our funders get their funding from, actually sometimes from grants from countries. They get them from, we had a team that got it from their alumni network of their university. So there are various ways and means to do this. So that's part of the whole process, though, is this is a competition, and this is why I put that slide up on how it differs from grants. It's not necessarily for everyone to do this. So that's one part of that answer there, is it's a very different model, but it pushes forward on innovation nonetheless.
That said, though, and I think there's a building question here in general about innovation, but there was also the demographic question,
yes.
And I think you've got some great news for us there.
That's the other half of that. Yeah, so demographically, we actually get contestants from all over the place, from all over the world, and from all age groups and backgrounds. So for Ocean Discovery X Prize, we had over 630 team members who worked in the last 3 years to make this happen, of which 30% were women. And bear in mind, this is a very heavily engineering field. So 30% were women. We had one of our winning teams, so part of that competition was $1 million NOAA bonus prize for an underwater, what we're nicknaming a smart sniffer. The winning team was a junior high and high school student team, which, you know, they're kids. We've seen them grow from the age of 13 to 16 or so in the last few years, and the confidence that they've gained. But they had the best technology and the best idea. So the idea is, again, they can come from anywhere, and it's not limited to demographics. And I agree, the funding is the issue. So perhaps there could be a grant mechanism for funding teams, or through universities. So Duke University set up an actual course to compete in X Prizes. So the students get credit, they learn about some area of the world. It's a real world engineering challenge. It's not rigged or, the teacher knows the answer. So there are various ways, and I'll be happy to talk about some of the other avenues that we've seen teams from. And then as for global demographics, we had a team from Ghana. We're getting more and more interest from across Africa, from South America. So it truly is a global effort. And those 630 team members came from over 25 countries.
Marlon, chime in.
Yeah, it's maybe the question has a little bit more of a broader, is a little bit more broader than it was originally anticipated there. And, I like to think in terms of the funding there that we might want to start looking at some of the other models for funding technology development that would involve more upfront investment by the financial community in companies that would be able to provide effectively data as a service to the oceanographic communities. I know that's not a popular thing with our research institutions because it takes a lot of their activities out of line, but I think it's not a bad approach. And if you want to see something I find is just remarkable is this Planet Labs. Go and take a look. This is a private company that on their own developed satellites that are now upwards 150 satellites or so that are imaging the surface of the ocean and the land to a resolution of 3 meters. All those pictures that you see of the Saudi Arabian destruction there this week have come from this little company in, well, they're not so little anymore, but in San Francisco that's building these CubeSats that are selling data to a broader community. I don't know if that model will work for our field or not, but it's something certainly I think that we need to investigate. Thank you. Planet Labs.
Wendy, did you want to chime in? Okay. So we have a clock up here. There is a special announcement. We're going to take one more question from the floor, but we need this. You need to present your question in like 15 seconds or less, and hopefully it's one that can be answered in sort of 60 seconds or less. So I'd invite, if you have such a question, bring it on. We welcome it.
Zach? Yeah. 60 seconds. Yes, Nadia Pinardi from University of Bologna, Italy. So this is all very exciting, but we are also, many of us here, looking for equity and for public good. Now, all you have shown is a lot of high tech that is done to produce money for the companies, and we want to work with them, but they also have to work with us and give their data for the public good systems, the services, and enhancing equity. Thank you.
So we'll invite sort of, it's a great comment, right? I think we've been working on that, technology, innovation. If you would like to offer some final remarks on that, we welcome those before we continue with the rest of the program. So just a few seconds each, please.
Yeah, thanks, Nadia. I, again, go back to the notion of working together from the beginning, but it does take work. Yes, the companies need to want to work with researchers, and the researchers need to want to work really with the companies, and it has to be a mutual respect from the get-go. Some researchers are easier than others to work with, some companies are too. So again, it's all about people.
I don't see a fundamental inconsistency there. I think it is absolutely, as Wendy said, about people and involving a partnership between the broader society and industrial performers. Thank you.
Yep. Good. Yeah. Okay. 60 seconds.
Thank you all so much for your insightful presentations and also the comments. I think we really value the contribution from your questions and the audience participation, and we really appreciate your time and your effort today. So can we please give our speakers a round of applause?
So as our plenary speakers here leave us, but not for the day, we're certainly pleased to bring one more special announcement to you. We did accelerate this to make some time for this, and I'm pleased at this time to welcome representatives from the United States Department of Energy and the National Oceanic and Atmospheric Administration, Daniel Simmons is the Assistant Secretary for Energy and Efficiency for Renewable Energy, and Ms. Nicole LeBoeuf is the Acting Assistant Administrator for the National Ocean Service, and they have a special announcement they'd like to share with our community. So.
All right, well, thank you very much. It is great to be here today. I really appreciate this opportunity to be here, be joined on stage with Nicole LeBoeuf from NOAA. My name is Daniel Simmons with the Department of Energy, as Justin mentioned. And given the unique concentration of knowledge and expertise in this audience, we thought this was a perfect place to make a special announcement. And that is that today, the U.S. Department of Energy and NOAA are jointly announcing a $3 million prize for innovations in marine energy-powered ocean observing platforms. As you know, ocean observing platforms encompass stationary and mobile technology, include autonomous underwater vehicles, buoyance gliders, profiling floats, weather and drifter buoys, and electronic tags for marine animals. And as you all know well, ocean observing missions often encounter power constraints that could be alleviated with marine energy. This prize seeks new ideas and technologies that integrate marine renewable energy with ocean observation, reducing energy limitations and leading to a better understanding of the oceans. The Ocean Observing Prize will provide innovators with a pathway from ideation to design and build, with 2 separate competition and prize awards made during each phase. The first competition, Ideation, will solicit novel concepts that pair ocean observing technologies with marine energy systems to address 5 broad themes. The first is charging unmanned, autonomous, uncrewed, whatever you want to call it, systems. The second, communications and underwater navigation. The third, extreme environments. The fourth, buoys, flats, and tags. And then the fourth, blue sea ideas. The prize will then have follow-on design and build competitions to bring innovators' ideas to reality. This prize is a core element of the Department of Energy, the U.S. Department of Energy's Water Power Technology Office's Powering the Blue Economy initiative. Launched in April of this year, Powering the Blue Economy seeks to unlock opportunities and reduce constraints and costs for ocean science, national security, and other maritime industries by exploring new applications for marine energy. For more information on the Ocean Observing Prize, I invite you to visit the Powering the Blue Economy webpage at energy.gov. You can also learn about the full suite of prizes being offered as part of this ambitious and timely initiative. Let me thank you all for being here today, and I encourage you to make before that. Also, if you would like to learn more about this prize, at 11:30 there is a panel, Powering the Blue Economy, led by Alejandro Moreno, the head of our Water Power Technology Office, and that will be in room 317. And with that, I'll turn it over to Nicole.
Good morning, everyone. I just want to briefly thank the Department of Energy. I'm so honored to be here on stage with Assistant Secretary Simmons, but I want to thank DOE and all of the team here for letting us be a part of not just this announcement, but the process from the beginning. I have to give it to DOE. It is because of their initiative that the phone rang and NOAA picked it up and they said, we want to be a part of this space. We want to provide support to this space, but we need your help understanding what the ocean observing community wants and needs and really can deliver. And so we said, yeah, let's do this together. I'm really, really proud of this collaboration, and we're so excited. We have experience at NOAA in advancing and supporting ocean observing platforms, but what we don't know, what I'm so excited about, is what data and insights and discoveries will be available when we can remove energy constraints from these devices. So we're very, very excited. On behalf of NOAA, the National Ocean Service, and the U.S. IUCE program, we want to thank DOE. I'd like to thank Dan, Alejandro, and his team for all their collaborative work with us, and we're really looking forward to seeing how this prize turns out. Thank you all.
Very good. So that is bringing us to the end of our morning session. Just a few housekeeping remarks for you. So you will exit this room and you will not find coffee. You will need to go downstairs to where all of the posters and all of the interesting technology exhibits are to find coffee. Please find your coffee, and remember that starting again at 11:30, there are a whole series of interesting sessions. There will be the panel here. Those of you who are voting up some of those very interesting Slido questions, we will address those here in that panel. And there are numerous breakout sessions that we welcome you to engage in. So unless Eric has a comment he wants to dive in on here, are you?
No, they should hear a 5-minute warning to get back.
Very good. So there will be a 5-minute warning announcement to remind you. So you can comfortably go get your coffees. Thank you very much. Come back for more Innovation Day in about a half an hour.